Good day. I'm going to continue the topic, which is electricity under Module 2. What are the different forms of electricity? A is static electricity. Electricity in general is classified into two, namely static and current electricity. The kind of electricity which is produced by friction or by potential difference is referred to as static electricity or electricity at rest. Lightning as an electrical discharge was discovered by Benjamin Franklin and his son Billy. The discovery of lightning as a form of static electricity was made possible through Franklin's famous kite experiment. The kite was equipped with a pointed wire and flown up into the clouds during a thunderstorm. A key was fastened to the end of the kite string, which made him feel the shock. The experiment was very dangerous one, but Franklin was unaware of this, that he did not think it may mean his life. Lightning is a natural phenomenon that strikes any tall object such as tree, person, or building in an open field. As a result of the experiment of Franklin, the lightning rod was developed by him. This device can protect tall objects like tall buildings during lightning. A lightning rod is a pointed metal placed on any tall building. A wire connects the rod to the ground. When there is lightning, the building is secured because the lightning bolt is caught by the lightning rod. From the lightning rod, the electrical charges of high voltage are relayed down to the ground. How static electricity is generated. Static electricity is a kind of electricity not in motion, or sometimes referred to as electricity at rest. This could be proven by trying this simple experiment. Rub your plastic comb on a wooden cloth, then place this comb near bits of paper. What happens? Take note that after rubbing the plastic comb with a woolen cloth, some electrons of the woolen cloth are transferred to the plastic comb, making the comb negatively charged. The comb is considered negatively charged because it has gained more electrons. The woolen cloth, on the other hand, since it lost some of its electrons, is considered positively charged. On the other hand, Charles Dufay, a French scientist in 1733, was the first to find out, based on his experiments, that objects having the same electrical charge repel each other. Objects having different or unlike electrical charges attract each other. Letter B, current, electricity. An electric current has charges which are in motion, causing this continuous movement of charges is the presence of a pressure called electromotive force, or abbreviated as EMF. The electric current is of two kinds, namely direct current, or abbreviated as DC, and alternating current, abbreviated as AC. Direct current electricity and electricity is considered a direct current if it flows in one particular direction. The usual direction of the flow is from negative to positive. This flow can be caused by chemical action, as in the dry cells and the storage batteries. Alternating current electricity, as the term applies, the direction of the current flow of this type of electricity is alternating current. This type of current electricity is commonly generated by an electrical machine called generators, particularly the AC generator. The three essential aspects of an electric current. Letter A, we have the electromotive force or voltage. The electromotive force is an electrical pressure that causes the movement of electrons to flow from one point of a conductor to another. The current flows through a conductor due to the differences in electrical pressure, that is, from one point of a conductor with an excess of electrons, which is negatively charged, to the other point with a deficient number of electrons, or the positively charged. The instrument used to measure voltage, another name for electromotive force, is electromoving force. It is called the voltmeter. Current flow. Under letter B, current flow refers to the flow of electrons from a point of origin which has an excess of electrons to a point of less electrons. That's why it is said that current flows from negative to positive. The quantity of electricity flowing in a given conductor is different upon the applied voltage and resistance of the conductor. An ammeter is an instrument used to determine the amount of current flow. The quality of current flow is referred to as the number of electrons flowing per second in a conductor. Letter C, resistance. The opposition to the flow of current is referred to as resistance. The ability to resist current flow classifies substances as conductor or insulator. Generally, all substances have varying resistance with respect to the flow of current. Practically, all metals have less resistance. They are considered conductors. Third is the advantages of alternating current over direct current systems. Because of their inherent advantages, alternating current systems have replaced direct current system in almost all modern utility power systems. The two major advantages of AC over DC system are as follows. Number one, lowering generating cost. An AC alternator is simple to construct with no need for a complicated split ring commutator. Thus, the AC alternator permits a higher speed of rotation with lower maintenance costs and a lower cost of power generation. Two, it is easier. Easier to produce its voltage transformations. The voltage of an AC system can be changed by the use of a simple piece of electromagnetic equipment known as a transformer. The transformer permits the transmission of large amounts of electrical power at a higher voltage for long distances with relatively small transmission lines and thus a lower cost of transmission. The distribution voltage is then stepped down again at the user's premises to utilization levels such as 120, 208, 240, 277, and 480 volts as appropriate for the connected loads. Transformers. Transformers are power transmission equipment primarily intended to convert the system voltage from one level to another. All transformers operates on the principle of magnetic induction. Primary and secondary coils are wound on a common silicon steel core. The incoming side is the primary. The outgoing side is the secondary. If the voltage is increased from primary to secondary, the transformer is step-up transformer. If the voltage is decreased, the transformer is a step-down transformer. With magnetic induction, voltage is induced from the primary to the secondary. The resulting voltage is directly proportional to the ratio of the primary to secondary winding systems. Conductors and insulators. In dealing with electrical transmissions, conductors as well as insulators go hand in hand. These materials are very vital. Anyone working with electricity should know their nature and value. Most conductors are metallic in nature. Each one has its own degree of conductivity with respect to current flow. It is so because each metallic substance contains varying amount of free electrons. A substance is considered a conductor if it possesses a great amount of free electrons. These free electrons are so loosely held that whenever an electrical pressure is applied, they flow, constituting what it is termed as current. The rate of transfer of electron is approximately 186,000 miles per second. Conductor is an electrical component that conducts and confines the flow of electrical current within itself. Conductors are made of high conductivity or low resistivity materials to minimize the loss of power and drop voltage. Normally, they are made of cylindrical form as wires, but they are also made in square or rectangular sections. Depending on their construction, conductors are classified according to the following characteristics: material, copper, aluminum, etc. The form is wire, cable, bus ducts, etc. Composition: solid, stranded. Its voltage class: 100 volt, 300 volts, 600 volts, 5000 volts. Its insulation can be rubber, thermoplastic, or asbestos. Its covering may be lead, aluminum, non-metallic, or cross-link polymer. Its temperature rating can be 60 degrees Celsius, 75 degrees Celsius, 90 degrees Celsius, 250 degrees Celsius, etc. Different materials, because of their different atomic structures, possess varying abilities to conduct charge. In some materials, such as metals, at least one of the electrons revolving about the nucleus of the atom's outermost orbit is very loosely held in the atom. We observed this be particularly true in the case of copper, where there is only one electron in the outermost shell. Consequently, it requires but a slight amount of energy to dislodge this valence electron, form the influence of its parent atom, and move it from atom to atom throughout the material. Materials exhibiting these characteristics are called conductors. In some other materials, there are few free electrons. As a result, it requires a great amount of energy to liberate any one electron from the influence of the parent atom. We observe this in the case of carbon. These materials are called insulators. The conduction of charge discussed above is known as electronic conduction because the electric current is carried by electrons. Materials display a different resistance to the flow of electric current. Metals generally have at least the least resistance and are therefore called conductors. The best conductors are the precious metals, such as silver, gold, and platinum, with copper and aluminum only slightly inferior. Conversely, materials that resist the flow of current are called insulators. Example of insulators are glass, mica, rubber, oil, distilled water, porcelain, and certain synthetics such as phenolic compounds exhibits this insulating property and are therefore used to insulate electric conductors. Common examples are rubber and plastic wire coverings, porcelain lamp sockets, and oil immersed switches. Electrical conductors are the materials that carry or allow the flow of electric current, while on the other hand, insulators are those materials that resist the flow of electric current. The following are some of the materials considered as the good electrical conductors. As mentioned, silver, gold, copper, aluminum, nickel, brass, zinc, platinum, iron, lead, mercury, and tin. Silver is so far the best conductor. For obvious reason, you cannot use silver as conductor in all wiring installation. Copper is used instead because it possesses the properties that make up a good conductor. It is less expensive and has free electrons. The conductivity of a substance varies with temperature. In some substances, conductivity decreases as the temperature rises. However, there are substances which increase their conductivity as temperature rises. Electrolyte is an example. On the other hand, substances which have no free electrons or substances which could hardly move their free electrons are said to be insulators. They serve as protective material and are placed around the conductor. Listed below are some substances belonging to this category. On the other hand, enumerated below are some of the materials considered as good insulators. They are rubber, enamel, porcelain, varnish, slate, glass, mica, latex, asbestos, thermoplastic papers, oils, bakelite, dry air, wax, and dry sealing board. Insulators are which have high resistance. They are usually non-metallic. Rubber is widely used as wire insulator. But then, this is good only when the temperature is not beyond 120 degree Fahrenheit. Beyond 120 degree Fahrenheit, rubber deteriorates fast. For magnet wire insulation, enamel is used. In cases where rubber is not applicable as insulating medium, the varnish cambric is substitute for it. Conductors insulators serves as a physical shield of the wire against heat, water, and others. Insulation is rated by voltage from 300 to 15,000 volts. If insulation is used above its rating, it might break down, causing short circuit and arcing, which may result to fire. Building wiring is usually rated from 300 volts up to 600 volts. Let us discuss the different trade names and the letter type and its operating temperature, so as the applications provision. Number one is the moisture and heat resistant rubber. Its abbreviation is RHW. Having 75 degrees centigrade. So it is applied on dry and wet location. For thermoplastic, it is abbreviated as T, having operating temperature from 60 degrees Celsius, and then it is actually applied to dry location. Number three is the moisture resistant thermoplastic. It is abbreviated as TW. Its operating temperature is 60 degree centigrade. It is applied to dry and wet location. Number four, we have heat resistant thermoplastic. Its letter type is THHN, having operating temperature of 90 degrees Celsius. It is used in dry location. Number five, we have the moisture and heat resistant thermoplastic. It is abbreviated as THW, having operating temperature of 75 degrees Celsius. It is used in dry and wet location. Number six, moisture and heat resistant thermoplastic. It is abbreviated as THWN, having an operating temperature of 75 degrees Celsius. It is widely used in dry and wet locations. For number seven, we have moisture and heat resistant cross-link thermosetting polyethylene. Its letter type is XHHW, having operating temperature of 90 degrees Celsius. It is used in dry location. Number 8, silicon asbestos. Having a abbreviation of SA. Its operating temperature is from 90 degrees Celsius. Widely used in dry location. Number 9 is the asbestos and varnished cambric, having an abbreviation of AVA. Its operating temperature is 110 degrees Celsius. Widely used in dry locations only. Circuit arrangements. The two basic electric circuit arrangements are series and parallel. These concepts are the same for both the DC and AC. Series circuits. In a series arrangement, the elements are connected one after the other in series. Thus, resistance and voltage add an electric circuit may be defined as a complete conducting path. So, meaning this is actually the wire itself. So, the path is the medium that is used is the conductor. It may be the copper. So, that carries the current from a source of electricity to and through some electrical device or load, and back to the source. So when you say load, these are actually the electric consuming devices. So a current can never flow unless there is a complete closed circuit. So when you say closed circuit, with the aid of a switch, and say closed, it means that in the layman's term, it is on. It should be obvious that because of the arrangement of the components, the current is the same in all parts of the circuit. A somewhat more complicated circuit, it is customary to refer to connection points on such wiring diagrams. The battery voltage may then be resisted across the load resistance. The resistance of two wires, the positive and negative terminals of the battery series circuits, have very limited applications in building wiring. Example under series circuit. The battery is rated at 12 volt. The line resistance, both wires, is 0.04 ohm. The battery internal resistance is 0.01 ohm, and the load resistance is 1.15 ohm. Determine letter A, current flowing in the circuit. So take note when you say circuit, this will be in a form of a wire already. That's why it is mentioned that it has resistance. And letter B, the voltage across the load. So the solution here for letter A, current flowing, is the formula. I actually represents current, and V, voltage, and R is in terms of its resistance. So therefore, for the voltage, you need to add here the different resistance. So you need to divide it. So I equals to 12 volts. Then after this, you need to divide it and add the entirety of the resistance. So 0.01 plus 0.02 plus 1.15 plus 0.02. So I therefore is 12 divided by 1.2, having a current flowing at 10 ampere. So when you see that the abbreviation is A, we are already referring to its unit as ampere. Letter B, the voltage drop across the volt is V represents the voltage and I times the resistance. So voltage drop therefore is 10. We are referring to the current having 10 ampere times 1.15 ohm. So therefore the voltage drop across the load is 11.50 volts. Parallel circuits. When two or more branches or loads in a circuit are connected between the same 2 points, they are said to be connected in parallel or multiple connection. Such an arrangement and its circuit should be apparent that multiple loads are across the same voltage and in effect constitute separate circuits. From this, we conclude that in the multiple arrangement, the total current in the circuit is the sum of the individual currents flowing in the branches, that is I is actually the symbol for current. Total is I1 plus I2 then plus I3. So in parallel connection, the flow divides between the branches, but the pressure is the same in each branch. Note that loads connected in parallel are equivalent to separate circuit. Superimposed into a single connection, each loads acts as an independent circuit that are unrelated to and unaffected by the other circuits. The parallel connection is the stranded or standard arrangement in all buildings and wiring. A typical lighting and receptacle arrangement in a room. Its fundamental principle to remember is that loads in parallel are additive. For current and each has the same voltage imposed, one additional point to remember is the Ohm's law. That current is inversely proportional to resistance. Thus, as a resistance drops, current rises. Normally, circuits will carry 10 amperes. But if by some mischance, such as deterioration of the wiring insulation, a connection appears between points, the circuit is shortened so that there is no resistance in the circuit. The current rises instantly to a very high level, and we have a short circuit. If the circuit is properly protected, the fuse or circuit breaker will open, and the circuit will be de-energized. If not, excessive current will probably start a fire. Common circuits in the home. Let us consider some of the modern wiring practices to gain an insight into just how circuits are divided into your home. Items like the water heater, the furnace, the overhead air conditioner will probably on separate or individual circuits. Each heavy-duty item may be operated from a separate 220-volt line, depending on total loads. The electric range also may have its own circuit. Normally, the fuse box or circuit breaker wiring identification will tell you this information. So this is where a diagram or electrical diagram becomes very handy already. But as the other circuits, and remember, when they are wired for symmetry, they are probably grouped as follows. When there are small bedrooms close together with a bath closed by, or in between, this will be on one circuit for lights accompanied by its receptacles. Letter B, the master bedroom and its bath and perhaps a hall will be on one circuit. The living room and possibly the kitchen lighting can be in one circuit. When the dining room and kitchen are close together, you may find the outlets on a common circuit. Although, remember, there must be a 20 ampere circuit individually in each of these two rooms, and a separate circuit for the dining room lights, maybe on the same circuit as the garage if these are close, or the hall lights maybe on the dining room circuit. Letter E, basement circuits are usually individually run because they are often used for workshop devices that are connected there. The lights, however, may be grouped with another circuit for rooms close by and on the ground floor. Letter F, dishwasher, garbage disposal, laundry washers, and dryers all may be on separate circuits or depending upon the demand in current. May be grouped in 1, 2, such as the dishwasher and garage disposal together. In general, the plan is to distribute the circuits so that there will be over the 12 to 20 a demand on living room between the bedroom, etc., and the 20 to 30 ampere demand on the basement or workshop. All other large electric items have individual circuits. There is another consideration which is important from a user viewpoint. That is the knowledge that all outlets in bedrooms, living rooms are wired so that at least 15 ampere can be drawn from them if there is no other drain on the circuit. You will recall that a 15 ampere at 120 volt is 1800 watts. So now 1800 watts, you need to divide 120 volt is equivalent to 15 ampere. By simple multiplication, you will also realize that the normal cloth iron draws about 1000 watts. So in terms of devices, the 1800 watt would be two irons operating on the same circuit. The idea here then is to be careful. When you use a heavy drain electrical appliances, use it on very lightly loaded circuit. So this is a reminder actually. So you need to become familiar how much is the current consuming device. In that way, the circuits won't overheat. How are the wires run from the fuse or circuit breaker panel to the various circuits? So this is done by having a base point in each circuit called the center of symmetry. Usually to which the primary pair of wires from fuse panel goes. So this base point will be a box such as the overhead light receptacle in a bedroom. All other branch circuit lines from the circuit will then run to this common point and connect to the main pair or wires. The run from the center base point to the fuse box is called the home run. A home run will be two wires, one white and one black of large enough size. So we recommend here number 14 to 10 usually to handle the entire load on the circuit. There can be as many as 25 home runs in a single home. Offices will have just as many, if not more, depending upon the kind of lighting and the kind of electrical equipment to be found in their office. When the architect sends his home plans to a consulting electrical engineer for the wiring and lighting planning and details, the layout, the sizes of the wires will be specified. the location of panels and switches, the kinds of light will all be included. So this is how important the architectural design is. In that way, it will fit the purpose of planning its electrical system.